Hello. God, it's a scorcher everywhere, far out. But my head is good. My head seems like 2 days. And got new encyclopedias. 1966, a 75, which is 3 sets of different ones, and a 1984. So that was a bonus. So three sets over 3 days or 4 days. There's so many different ways it's going to do this, but why not do them all? We'll start with Galilei, lanterns. So the first person in 1667, Galileo, decided he was going to have a bash at working out the speed of light. Right, 1667. Now, if he is who they say he was, there is no way in a million years, right, that he would have even gone to that hill to work out if he could do it with an assistant on one hill and an assistant on another hill at night. How was he going to do the timing? What was he going to do? These are the things. It's ridiculous. Alexa, how did Galileo measure the speed of light?
Here's something I found on the web. According to main.edu, Galileo tried to measure the speed of light by placing 2 assistants with lanterns 3 miles apart.
2 assistants. Two assistants. Was it 2 miles apart, 2 or 3 miles apart? Alexa, how did Galileo measure the speed of light?
Here's something I found on the web. According to main.edu, Galileo tried to measure the speed of light by placing 2 assistants with lanterns 3 miles apart.
Alright, so it was 3 miles apart. And we've got the same one. Alexa, did Galileo measure the speed of light?
From Socratic.org, Galileo did make a measurement of the speed of light.
Alexa, how?
I missed something. Can you say it again?
Alexa, how did Galileo measure the speed of light?
From Wikipedia.org. In 1638, Galileo Galilei proposed an experiment with an apparent claim to having performed it some years earlier to measure the speed of light by observing the delay between uncovering a lantern and its perception some distance away.
Alexa, how many assistants did Galileo have?
From Coursero.com, Galileo and his assistants, Andrea Sati and Fay Bolzoni, encourage members of the court to look through the telescope and see the truth with their own eyes.
Alexa, how did Galileo measure the speed of light back in 1667?
From Lyco.co.uk, Galileo Galilei attempted to measure the speed of light with an experiment in the early 17th century that involved 2 people and covered lanterns standing a known distance apart. Did that answer your question?
Kind of.
Thanks for your feedback.
Look, there's so many versions. Alexa, did Galileo have 1 assistant when he was working out the speed of light?
According to an Alexa Answers contributor, he had 1 sister and no brothers.
Real funny. The point is, right, there's always a different story. But the bottom line is, if this Galileo, is the brains that they say he is, he would never have ended up on a hill in the dark with an assistant 2 or 3 miles away. Because first of all, how is he going to time it? What is he going to do? It's night time. What is he going to do? How's he going to write anything down? Again, the whole thing, it's so stupid, right? It's so stupid that they've got to give it 3 crosses. I don't even know what that was. It's on the form, on that sheet of the list. 333 of whatever. So maximum is 5 crosses. If it's 4 crosses, there's a small chance, etc. Let's go straight into Roma. Right. Alexa, how did Olaus Roma measure the speed of light? This is a joke.
From spacetimetravel.org. In 1676, Olaf Roma concluded from observations of the moons of planet Jupiter that the speed of light must be finite.
Right. Alexa, what was the speed that Olaus Roma worked out was the light coming off of the sun?
From autotrader.co.uk. The Ferrari Roma offers a top speed range of
Alexa, stop. Alexa, what did Olaus Roma work the speed of light from the sun out to be? Alexa, how did old Roma work out the speed of light from the sun?
From interestingengineering.com. By using a series of cogwheels and light sources, he estimated the speed of light at around 195,732 miles per second, 315,000 kilometers per second.
Okay. Alexa, what did Olaus Roma achieve?
From gold.com. Roma won the first major European tournament in their history when they defeated Feyenoord 1-0 in the Conference League final.
Okay, Alexa, the bottom line is, right, with this Olaus Roma, he was using a telescope. Right? He was using a telescope. So even if there was a time delay, which there isn't, right? Even if there was a time delay of 5 days, he would not have picked it up because he was using a telescope. No, right? That is the lockout reason, all in, full, right? He was using a telescope, there would not be any time delay. Doesn't matter what the distance, right? Because he's using a telescope. So they messed up on that one, right? 5 no's. Even if they haven't, right? No, it's not even worth talking about, right? He was using a telescope, so it's dead in the water, right? There's a load of other reasons. One, you don't work something like that out over 8 or 9 years. You don't have any measuring devices, do you? All you have is pen and paper. So what would he write tonight if he'd done one of those tonight? With what time is it? What time is it? What kind of logical timekeeping would he have had to make these records? It's just ridiculous. It really is. And it falls apart as soon as you go out in the night, at night, and look up at the sky and find Jupiter. Forget it. It's just never going to happen. And the reason that it's probably over 9 years is because if anybody questions it, they go, well, no, you have to do it over 9 years to prove that it can't be done. It can't be done. You can tell that on the very first night of the very first measurement. But that's all irrelevant because he was using a telescope. So there would be no time delay. It's common sense. Everybody should know that. Should we do James Bradley for kicks? Right, let's do this stellar aberration. Alexa, how did James Bradley use stellar aberration to work out the speed of light? It's ridiculous again.
From Cambridge.org. By analysing measurements of stellar aberration angle and applying those data to the orbital speed of the Earth, Bradley was able to arrive at the remarkably accurate estimate of 183,000 miles, 295,000 kilometers per second.
And another thing with Roma, kilometers didn't come out until the late 1800s. That was another reason, all right? It's just dead in the water. Stellar aberration, did you hear that? By looking up, you pick a star, and that star could be somewhere else. You know that whole 8 minutes and 20 seconds it takes the sunlight to reach Earth? Well, when you're looking at a star, you know, big distances, right? So you've got to decide which one you're looking at. The one that might be there, that isn't there, but, or the one that you're looking at, but is it there? And, you know, and then you've got to multiply the speed that the Earth is travelling as well. And thus James Bradley was able to work out the speed of light. Look, it's so bad. They're all so bad, right? So James Bradley, I'm going to give you, I won't give him 5. I'm going to give him 4. 4 no's, definitely it didn't happen, just because I know a bit about stellar aberration, but I don't want to get caught with my pants down, do I? So I'm going to give him 4. It just did not happen. Stellar aberration. Alexa, what did Charles Wheatstone discover in 1834?
From testbook.com. In 1834, Charles Wheatstone achieved the measurement of electricity's velocity using a revolving mirror and miles of wire, a milestone in understanding electricity's properties.
Wow. God, Alexa. Alexa knew him. Alexa, who's Charles Wheatstone?
Sir Charles Wheatstone, FRS-FRSC, was an English scientist and inventor of many scientific breakthroughs of the Victorian era, including the English concertina, the stereoscope, and the Playfair cipher.
Okay. Alexa, did Charles Wheatstone have a revolving mirror?
From OrlandoSentinel.com. He has received a patent on a mirror that circles around you so you can see the back of your head.
All right, Alexa, how exactly did Charles Wheatstone work out the speed of light in 1834?
From ResearchGate.net. In 1834, Charles Wheatstone measured the velocity of electricity along 2 long wires, whereby he found a velocity of about 463,500 kilometers per second, over 1.5 times the speed of light.
Right, how? How did he do that? First of all, power didn't come in until 1880. So they're still playing about with wires and stuff like that. How on earth would he have been able to measure the speed of electricity in 1834 with wires, right? Of course they're no's, right? All he's got are wires. Alexa, how many different wires did Charles Wheatstone have in 1834 to work out the speed of light?
From ResearchGate.net. In 1834, Charles Wheatstone measured the velocity of electricity along 2 long wires, whereby he found a velocity of about 463,500 kilometers per second, over 1.5 times the speed of light.
It's insane. How? It's annoying. It's annoying, right? Because it just really is annoying, because the bull, right, is unbelievable. How can a rotating mirror? So you're rotating this mirror, and light's bouncing off from one tooth onto another mirror, back onto whatever tooth you're rotating. What exactly gives them that speed? Is a shadow in a certain place, it's like 200,000 kilometers per second? And if there's two shadows, it's 250,000? How does that work? It's beyond a joke, if you're this. Oh, nearly. All of it. This next guy, a rotating mirror, but there was no speed. There was no reading on there. Armand Fizeau, a rotating wheel with a light bouncing 16 kilometers before electricity was out. How is it even possible, right, that they've given these as examples? They're all stupid. They're illogical, aren't they? All of them. There's not one here that really makes any sense. Not one of them. We've got to, haven't really looked into the Leon Foucault rotating mirror, because we don't usually get this far. Then we've got this James Clerk Maxwell, Marie Alfred Cornu. Now, where is it? Louis Essen. I did find him in one of the new encyclopedias. It's the only name, because the other night I gave him the boot because he wasn't in any of the books, but I did say there was going to be more books coming. So, and he's in one of them. I think it was the 1975? Anyway, his name was in one. But that's 1, 2, 3, 4, 5 he wasn't in, and he's in one. There's still another 2 that I've got to look at. You know what, let's do it now. Let's do it now, and then that'll be it. We'll call it. So I found him in this one. Where is it? I did not see that coming either. L, B, L, B, N, B, R, B, S, S, T, House, Estonian, that was in this one, Histories, that was in this one. This one encyclopedia set had 3 sections to it, far out. Yeah, this was the one. Essex. Essen, there we go. Essen Lewis. 1908. Mm, 1947. Down there. Inventor of the Essen quartz ring clock, widely used as a time standard in observatories, and builder of the atomic clock, Celsius standard. In 1929, Essen began work on frequency and time standards at England's National Physical Laboratory, Teddington, Middlesex, making studies of tuning forks and quartz oscillators. His investigations culminated in the quartz ring clock, 1938. What was that? 1947. During World War II, he invented a number of radio wave measuring devices that led him in 1950 to measure the speed of light at 299.7925. At 299, we've got 792. All right. So he is in the 1975. So he's in the 1975. Right. So let's go back to the beginning, 1961. G. Eskimos, esophagus, Esparto, Esperanto, essential, esters, estimation, etchants. It's not in 1961. In 1966. Electric, ethics, Eskimo, Esperanto, essay, Essen, but Germany. The largest industrial centre in the Ruhr, Coalfield, West Germany, Essen. So, no, in 1966. Now let's go to the surprise a couple of times this jewelry collection, isn't it? Espionage, Essens, no, Essen, right, so that's 1961, 66, 71, it is in 75, now let's have a look in. No, I've looked at these, haven't I? But we're double checking. Mm, 1979. So we're still looking for Louise Essen. Right, this is the World Book, 1979. It's boring, isn't it? But how else are you supposed to look this stuff up? There is no other way, is there? There is no other way. You rely on other people, and then, yeah, look what happens. Everybody believes everything. Estivation. Essay. American essays. Essen, no, in the Ruhr Valley. Is one of West Germany's, and then Essen were members of a Jewish sect. There is no Essen. So that's 1979. So now we're going to do the new one, 1984, the year I joined the army. See, I mean, if he's not in this one, education, electronics, ethics, essay, Essen in the Ruhr Valley is one of West Germany's, no, exactly the same, Essen is, no, so nothing. In the World Encyclopedia, 1984 either. And the last encyclopedia is 1990 that I had. And EU. So, let's all go over this one. Ethiopia, Ether, Essenite. Back. Essex, Esslingen, Essex, Essequibo, essential oils. Essen, city, West Germany, North Rhine. Essence. There is no Essen. So what do you do with that now? What do you do with that? Just looked in 1, 2, 3, 4, 5, 6, 7 encyclopedia sets, right? And the only one Essen is in 1975. Now that's not very convincing, is it? So now what? I mean, you'd think he's worked out the speed of light with a cavity resonator. You'd think that he would be in more than one. Then I've got my biography book with just the names. Sure, we checked in here. G. Einstein, Eliot, Emin, Esther, Essex, Escoffer, Essenian, nope. So there's no, this is a good book. Nothing there. We've got the 1967 Pairs Encyclopedia. Affairs, science. Prominent people. L. G. F. Erasmus. Evans. Euclid. No. So we've got the no. Ericsson, Irvine. Straight to T. There you go. That's the 1967, 1968. And then we've got 1975, 76. So it was in the 1975, the big one, when people, J, and yours, Erasmus. Essex, Earl of, no Essen. Right, that'll do for tonight. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And he's only in 1975. What do you do with that? You have to dig some more, because that throws the cat amongst the pigeons, isn't it? 1. There's no other way of looking at it, right? You can trust anything they say with this. So we'll put a question mark, but then you've got to say to yourself, a cavity resonator. Alexa, what's a cavity resonator?
Cavity resonator is usually related to resonator, a hollow enclosure, cavity resonator, made of conducting material of such dimensions that electromagnetic radiation of a certain frequency will resonate.
Did that answer your question? You hear that mango drop? Alexa, did somebody work out the speed of light with a cavity resonator? Alexa, did somebody work out the speed of light with a cavity resonator? Alexa, who's Lewis Essen?
From fandom.com. Lewis is a primary protagonist of the Epic New Alliance franchise and is the leader
Alexa,
of the
stop. Alexa, who is Lewis Essen, 1947?
From spy.org. Louis Essen's 1955 invention of the first practical atomic clock changed the basis of timekeeping from the periodic motion of the Earth, as recorded by astronomers, to the periodic motion of electrons in cesium atoms as measured by physicists.
Atomic clock. Hello? Was it not an atomic clock? How relativity started? Alexa, didn't relativity start with an atomic clock that was slow?
Sorry, I'm not sure about that.
Alexa, what is atomic clock and relativity connection? Where's the connection?
From encyclopedia.com. Atomic clocks have been used on jet planes and satellites to verify Einstein's theory of relativity, which states that time slows down as the velocity of one object relative to another increases.
Yeah, all right. Why? Why would that happen? Why? Why would that happen? Why did that happen? Alexa, is relativity logical?
From physicsforums.com. Relativity is perfectly and completely logical.
Alexa, is Einstein's theory of relativity logical?
From ozpublishers.com. Einstein's general relativity, the geometric theory of gravity that has become the accepted definition of gravitation in modern physics, is fatally flawed.
No, I'm being objective. Alexa, why is Einstein's theory fatally flawed? Why? Why? Do tell.
From physicsforums.com. In summary, Einstein's theory that the speed of light is always the same was flawed because he assumed that any observer moving at a constant speed would have the same laws of physics.
Obviously, I can see how that would fail. So Alexa, how did Louis Essen work out the speed of light with a cavity resonator? Alexa, how did Louis Essen work out the speed of light with a cavity resonator?
From wikipedia.org. In 1950, Louis Essen determined the speed as 299,792.5 plus minus 3.0 kilometers per second using cavity resonance.
Oh, cavity resonance. Really? What a load of rubbish. Oh. The thing is, they fail from the very beginning and everything is connected. Alright, that's it for tonight. We'll crack on with some of the others tomorrow. We'll crack on with Francois Aragon. So those guys, the first four, Galileo, look, no, that did not happen, right? He's not stupid enough. If he did all the things that they say he did, he wouldn't be stupid enough to go out onto a hill with assistance in the middle of the night. He wouldn't do it. Olaus Roma, it's a joke, it's a lie, because the telescope that would eliminate any time delay. James Bradley and stellar aberration. Oh God. Alexa, how did James Bradley use stellar aberration to work out the speed of light again, please?
Here's something I found on the web. According to creation.com, in fact, James Bradley figured out the speed of light to a high degree of accuracy by simply looking at two stars every night in a telescope that was strapped to his chimney so that it could not move.
So it was strapped to his chimney so it could not move. This is cute. Alexa, how did James Bradley strap the telescope to his chimney?
From discovermagazine.com. Bradley learned he had to tilt his telescope slightly in the direction of Earth's motion to keep the star centered, just as you might tilt a glove to catch a falling baseball on the run.
So now all of a sudden, there's a telescope and he's got to keep it centered onto the star. Alexa, how long did James Bradley take to work out the speed of light with his telescope that was strapped to his chimney?
From standrews.ac.uk. From his observations, he was able to calculate the speed of light, claiming that light from the sun took 8 minutes 12 seconds to reach the Earth. Today, we make it 8 minutes 20 seconds.
Did I just go over a speed bump or something? Alexa, how did James Bradley use stellar aberration to work out the speed of light?
From slideshare.net. In 1728, the speed of light was calculated by an English physicist named James Bradley using stellar aberration.
Alexa, how long did he have to look at the two stars? James Bradley, how long did he have to look at the two stars to work out the speed of light?
From answers.com. At the speed of light, it would take about 100,000 years.
Alexa, stop. Alexa, how long did James Bradley have to look at the two stars to work out the speed of light in 1726?
From conspiracyoFlight.com. The effect was first discovered by James Bradley in 1727 after he observed that the apparent position of the star G Draconis when viewed directly overhead would change over the course of a year of observation.
Alexa, how long did James Bradley have to watch the two stars to work out the speed of light in 1726?
From wikipedia.org, Bradley, who succeeded Halley as Astronomer Royal, calculated a value of 8 minutes 13 seconds for light to travel from the Sun to Earth.
I'm not getting a straight answer. Because there isn't. It's all round and round. How? Rotating mirror. What is it? At what speed are you doing 200? Oh, God. How can people believe this rubbish? Prove that they didn't, came the cries. Prove that they didn't. No, they need to prove how they did this, because none of it adds up. It's just so vague. This is what I mean by there's never a definitive. Alexa, how many times did James Bradley have to rotate the mirror to work out the speed of light?
From StackExchange.com, Michelson built an octagonal solid with mirrored sides which spun at several hundred times per second, and used this spinning mirror to measure that light took about 230 microseconds to make the 44-mile round trip between Mount.
So how do you work out microseconds before power? And this is, oh hang on, this was Michelson, wasn't it? So that was in 1926. Alexa, how long did James Bradley have to watch the two stars for to work out the speed of light? Sorry, I said...
From aqualibraries.org.
I got the wrong one.
One wintry night in 1725, James Bradley and Samuel Molyneux aimed a 20-foot telescope at Gamma Draconis in an attempt to discover stellar parallax.
Rubbish, all of it. Alexa, how do you use parallax? It's another one.
From Byju's.com. Astronomers use parallax to find the distance between adjacent stars in the universe.
Alexa, what is parallax? What do they do? What's the method used?
From Space.com. The method of parallax is used to measure distances to nearby stars.
Alexa, how do you use the parallax system?
From Calcicode.com. Parallel systems are designed to solve computationally intensive problems quickly by dividing the problem into...
Alexa, how is the parallax system used to measure the distance to stars?
From HowStuffWorks.com. Astronomers can measure the distance by using a method called parallax, in which the change in a star's position in the sky is measured at different times during the year.
So, it takes about 6 months, doesn't it? So if I was wanting to measure the distance to a star, I'd do it tonight, and then, what is it, January, June, July, couldn't I? So it'd be February, March, April, May, June, July. And then I'd have to find that star again, and because 6 months are on the other side of the sun, when I look up at that star, what if the stars moved? What if the stars moved? I mean, it's not going to be a fixed point, is it? Is that not a valid question? Of course it is. What if the star moves? It's the first thing that springs to mind. All of these things just fall apart. All of them. Every single one. So parallax. So the sun's there. Earth's on this side, and somebody picks out a star. I don't know. Anywhere. Up here, right? The guy looks at a star, and then 6 months later, when Earth has done half of its orbit around the sun, then looks at that star again. It's something to do with the angle. What if the stars moved? How do we not know? See, straight away, how is that going to tell you anything? The star could have moved. It's not fixed. Just like that. Oh yeah, but what? It's just one thing after another. And the parallax angle is over 6 months from 2 different locations, but you're actually using a star. So the star could move, couldn't it? What's that going to do to the reading? Anyway, that's it for tonight. Back tomorrow. Probably tomorrow early morning with something. Telling you, everything is connected. Once one fails, rest follow.